So hello, everybody. I'm Eric. I work at Moderna. My official title is Senior Principal Data Scientist in the Data Science and Artificial Intelligence Research Team, which really just means we are computer nerds, data nerds, biology nerds, and chemistry nerds all together. And that's just a little bit about my professional background. I think what's more relevant for today is that when I finished from grad school about 7 years ago, I was really into this idea that like scientists need to learn how to code well, need to learn how to organize their work well. And I'm really glad that there's this, a fall festival happening, because it's teaching all the things that I wish I was taught 8-9 years ago in graduate school. I think the way that I would like to open up is I think we should engage in a round of roast your repo. And so what I'm going to do, I'm not going to ask anyone to roast their own repo. I'm going to ask you all to roast my repo. And so I'm going to drop a link in chat. And I'd like you to open it up. Let's see if this works out. Leah, if this is feeling a little out of left field, because I just decided on this like 3 minutes ago. So we're going to engage in a round of roast my repo. I'm going to ask you all to take a look at it. I'm also going to share the repo link on the screen so that we have it for posterity on YouTube as well. I see Julio, I hope I'm pronouncing your name correctly. No folders, very good, very good. Rowan's going, it has not been updated in a decade. Yep, that's right. This was my thesis code. It is frozen in time. Anything else? Hugo is saying no continuous integration. Yep, Melissa, thank you. Yes, there's a README, and that is more than most genuinely. Yes, generally speaking. Dan has pointed out there's no requirements file, and I have this weirdly named _sh.py, which is like, is this supposed to be a shell script, or is this supposed to be a Python script? Requirements cites Python 3.4. Yes, Kevin, like that. In today's age and world, that would be like way too outdated. I would have needed to update this code to be inside a Docker container if I was too lazy to even keep this up to date with the latest evolution of Python. Okay, so thank you, Leah. I have a license, and Julia, absolutely correct. I did not make any changes via pull request. It was just me commit to main, push to main, push to main, push to main. Okay. Guess what? This was like 8 or 9 years ago. So 9 years ago was 2015, and I believe the first version of this code came up before I took the software carpentry courses. The software carpentry courses were when I finally realized, oh shoots, I shouldn't have done all of this in such a haphazard way and just put my code up in a haphazard way. So having this training course today, I'm hopeful will be really useful for you all. So I'm going to stop my screen share now. I do want to share a little bit more about the background of this code. Actually, maybe not. Maybe I'll continue on for just a little bit more. You scroll down, you'll notice what this code base is supposed to do. It's part of my thesis code base, and it's called the influenza reassortment detector. Just to simplify reassortment in influenza for you all, the flu genome is composed of 8 genes, and so that's like having 8 cards, A through ACE. You can have 2 viruses that are of different lineages. So that's like having a red deck of ACE through 8 and a blue deck of ACE through 8. And if those 2 flu viruses co-infect the same host, the progeny virus that comes up can have a mixture of red and blue, or virus 1 or virus 2 genomes, which is like shuffling the deck of red and blue cards and picking an ACE, a 2, a 3, a 4, a 5, a 6, a 7, and an 8. Okay, so my thesis code that you're seeing up here is designed to detect from a 16,000 in large influenza research database, which is still a resource that exists to this date. The influenza research database housed 16,000 influenza genomes, and my goal was, can I figure out which one of these viruses were reassortant viruses? I'm not gonna go into too much detail about how the method works, But we did get, the end result was we were able to putatively identify a whole bunch of influenza reassortant viruses when I did the work from one snapshot of the influenza research database. And then we published a paper that was basically asking, does genome reassortment coincide or correlate somehow with post-switching events? And the answer was yes. We didn't overturn any dogma. One of the things, the more important part about this story that is more relevant for today is that we did this on a snapshot of time on the influenza research database. And so you can imagine as the database gets updated, we should be able to continuously update our knowledge of what exactly is a reassortant virus. Perhaps with an update of like a bundle of sequences, something that we thought was a reassortant turned out not to be, because there was extra information that said, oh no, actually there was like more clonal evolution that resulted in it. And that means we need to keep the software running. So during my time in grad school, I was actually in touch with the influenza research database team. And there was interest in, can I take this code? Yes, this code, and have them use it on the influenza research database. Now, we were in lots of talks even after I graduated, and I was really excited. I was willing to volunteer outside of work to just make this happen, because it represented the rare thing that most PhD students don't get to experience, which is the ability to see their work actually become impactful during the time or shortly after their PhD finishes. And so I really wanted to make this happen, but it never did. Now, I can't divine what happened behind the scenes in the influenza research database team, but I think my code's quality was one of the contributing factors. This is incredibly hard to maintain. If you think about it, I have a paired set of Bash scripts and Python scripts, which are like, what's going on there, right? The documentation, while I tried my best to make it runnable over time, was really designed against a SunGrid engine cluster, so it was not necessarily portable from computing system to computing system. I mean, what if people had to run this on a Slurm cluster instead? Or even more, what if they didn't even have, what do you call, cluster computing resource instead, and we're working on the cloud, which was already a thing back in 2016. So lots of factors converged to make it such that I never got to realize the impact of my thesis work. I did get to graduate, so that was great. I got a paper out of it, that was awesome. But the work could have been more if I had known better how to structure my work and how to make it portable, better documented, and all of those good things that you're going to learn today, learn this week in the Fall Festival. So I'm going to stop my screen share now, and I'm actually going to switch to a different repository. We'll do another round of Roast My Repo. So let me switch over to this guy. Okay. All right. This is another repository. Go ahead, roast my repo. Sorry, yes, I'll put it. Very good point. Thank you, Rowan. Let me put the link here in chat. This one was one that I talked recently about at SciPy this year. So let's go for it. Roast my repo. There's no binder link. I feel X-rayed, Carol. Thank you. That's right. There's some things that look like they need to be in a good ignore. I'd love to see which one. The 404 on the docs. Clearly, I still have some lessons to learn. Let's keep going. Keep them up. The VS Code folder. That one, that's an intentional design choice. I actually want people to share peacock colors in VS Code. So that was an intentional design choice. But I can appreciate that one. Yes, yes, exactly. Yep, the 404 on the docs. Okay, you may notice a theme. There's in the 3 minutes that I open it up for roasting, there's actually fewer ways that this repo was roasted. And that talks a little bit about the idea that this stuff is learnable as a scientist. And I picked it up over the years. I didn't learn it in one overnight. Like if you look at my repository history, I have 300 plus repos created. About 95% of them are defunct repos. I don't maintain them, but they were all just experiments in me trying to get better and better and better at organizing my work. So before I launch into the main body of what I want to talk about, I just want to preface everything by saying this is all learnable. This is not difficult. It is more about being disciplined about how you think about your work. And if you can apply and gain these disciplines, you'll become better as a programmer. Your work can then have a higher chance that it'll realize its impact. So let's talk about what I really wanted to talk about today. So I'm going to actually stop the screen share. So let me just do that. Stop presenting. Okay. I don't have slides. The way that I prefer to do my talks nowadays is I prefer to write out what I want to say, and I'll talk about it live. And then at the end, I'll share a link to the blog post so that you all can see can have something that's a little bit more concrete of an artifact. I know that I tend to make very sparse slides that are very hard to follow. So rather than leave you with a sparse amount of content that may not benefit you, rather leave you with something a little bit more substantial. So yeah, it's been 8 years since I did my thesis code, 8 to 9 years. And in that intervening time, I've learned that to make my work portable, to make my work fully realize its impact, there are 4 fundamental practices that I need to keep in mind. That is the documentation, the idea of making my work able to be easily run across different machines, to keep my code modular, and to keep my code tested. And if I can apply these 4, then these are the 4 things, by the way, that you will learn during this fall festival week. So if you keep that in mind, it'll definitely benefit how you do your work. And so the training course is going to teach you the what. And what I wanted to do is give you a little bit more about the why. Hopefully seeing my repo and roasting it, like my thesis code, gives you a really good, really strong sense of why it's important to engage in these practices, right? To make sure that your code is documented, portable, modular, and tested. But beyond that, I wanted to give everyone framework for thinking about the psychology behind why it's so important to engage in these practices, right? And so I'm going to explore these with 3 key concepts. And the first one is about the readability and cognitive load. The second one is and how that impacts how you might want to go about your work. Second one is how the psychology of installation and getting set up, and how that can hinder progress or actually enable your work. And 3, the third key concept is like how people come to understand what you're trying to accomplish with your work through documentation. All right, so let's go through each of them. The first concept is on readability and cognitive load, right? So if you think about it, within the Zen of Python, it's made really clear that readability matters more, right? Matters a lot. Readability counts. It is actually 1 line in the Zen of Python. And the design of the Python language wasn't designed for performance first, it was designed for readability first. And it's really crucial because, yes, performance can be really important economically in many situations, but for the vast majority of us, just being able to understand what a person is doing through Python code is really important. It is actually the bigger bottleneck, right, of how we go about our work. But to think about it, most of the code that I write gets run twice or thrice, right? And then it needs to be handed off to someone else for further modification, and then it comes back to me, right? So there's this collaborative aspect. And the onboarding time costs more than in terms of pure economic costs. The onboarding time for someone costs more than the actual runtime of the code most of the time. And so readability is really important here, right? If you think about it, it is a language. Python is a language, and so it is intended to be read by someone else. So if your code is readable, it has quite a number of significant benefits. The first one is others can onboard faster if you organize your code in such a way that logical things are grouped together, unlike my thesis code. Then you'll find that people can understand the logic and flow of your work more easily. The second one is also you yourself, 6 months from now, are a different person from who you are today. And you're liable, if you don't work on that thing for a little while, you're liable to forget how you structured and organized your code before, unless you had really strong patterns for how you structure your work. And so code that is easy to read also then that code becomes easier for you to debug, update, extend, save you lots of time in the long run. Readable code also enables that collaboration, right? Comprehension and collaboration, not just for yourself, but for others, means you can build on each other's work more effectively. And that reduces also the likelihood of errors. Like if you can comprehend your code and make it easily translate from Python land to plain English land, that's actually a very great signal that your code is understandable and you're likely not making any major logical errors that you can see in the code. And that ultimately just makes your code more robust, more reliable in the long run as well. So as you probably saw from my own thesis code, it was poorly modularized, it was poorly documented. You know, like if you opened up one of the Python scripts, it'd be a horror show. The deployment was difficult. So it was really, that really did teach me a lot with respect to this idea of making my code readable, making sure that it follows patterns that others can follow easily. I think there's something poetic about good code. Good code, well-written code will have a poetic nature in that it will flow with you know, what do you call those? Verses, and there'll be logical verses inside that poetry, or sorry, inside that Python code. You will see a certain elegance within how that code is written. Granted, that is a very high bar. I don't think it's reasonable to expect anyone who is just starting out to achieve that bar. After all, there is good advice. Don't compare your chapter 3 to someone else's chapter 23. So make sure, but it is something good to inspire, right? Aspire to, right? So you make sure that you are headed towards a place where your code becomes aesthetically pleasing as well. And that aesthetic nature can also help a lot with readability. Okay, so that's the first idea. The first key concept is that if you can make your code readable and it is therefore more comprehensible, and therefore other people, which includes your future you, who is a different person from who you are today, other people will be able to onboard much faster. And if you do what I do and put all your work, as much of your work on GitHub as possible, it'll reflect well professionally on you as well. I keep my thesis code up on GitHub for moments like today, where I can get other people to roast it and make sure that they can learn from the lessons that I've learned. And it also reminds me that I was once there before as well. I was once a beginner. Okay, so that's the first concept, readability. Now, let's think about the second concept, user-friendly installation and setup. I do want to take a quick poll. How many of you were around dabbling in Python when you had to install SciPy in 2013? Carol was there. Anyone else? Anyone else? Lots of people. I see that. I see the thumbs up in there. Yeah, there were the easy install days, as Dan Chen is mentioning. Those were horrible days for installing Python and installing SciPy particularly. I actually remember 2014 was when I decided I needed to use something from the SciPy sparse library, and I needed to install SciPy, and I thought everything was as easy install SciPy, some package name. So I tried to easy install SciPy on my Mac and was immediately hit with compilation errors. Oh my goodness, right? Can you imagine me, the poor, what was it, 1-year-old Python programmer? So 2013 was when I really seriously started. So 2014, trying to install SciPy, trying to get scikit-learn to work with like this installed version of SciPy. And oh my gosh, it was a horrible nightmare. Think about the psychology of a person in those shoes. They try to install, they're trying to accomplish what they're doing. So in my case, I was trying to accomplish my thesis, make my thesis move forward. If I were not persistent, not of the temperament where I'm just going to try to bash through walls as much as possible, I would have given up and said, Python's not for me. I'm going back to MATLAB, because MATLAB at least could do some stuff that I might have wanted to do. Or I might have like hacked things together where I'm like, Python for this little bit here, MATLAB for this little bit there, a little bit of Bash, and Perl was still a thing back in the day in scientific computing. So a little bit of Perl scripts, and my thesis would have been drastically delayed had I had to context switch between multiple languages, and instead of, trying to install SciPy and getting it to work, right? So if you think about, though, the impact of your work, if you can't get your code into the hands of someone else, distribute it so that they can use it, then you've lost them as your potential outlet of impact. Right? That person is no longer, very likely not going to try to use your work anymore, right? So you might have actually permanently lost that person. And so it's a really important thing for you to remember, if your thing is complex and they're under time pressure and they're having frustration trying to install things, who knows? They may have this like imposter syndrome that develops as well. That's like, oh man, computing's not for me, right? It's just too difficult. Not only have we lost a customer of your tool, we risk losing a person who could use the language that we all know and love to make something really impactful for the world, right? And so this psychology of installation friction, I think, is one that's really important to keep in mind, right? If you are engaged in intellectual self-pleasure, that is one whole thing, right? That is another thing altogether. But if you want to build something that is intended to be useful to someone else, such that you can deliver impact through the code that you write, the analysis that you make, and you want to make sure that other people can trust it and be reliable, the distribution aspect is really important. Having user-friendly installation and user-friendly setup. So it's really important to keep that in mind. You'll be given the tools to make your project work distributable to other people during today. And of course, as Leah alluded to, the iOS packaging guide is a great place to start as well. So I would strongly encourage you to keep this in mind when you're thinking through and working through, man, how do I get this setup.py or pyproject.toml configured the right way? Is there some incantation that I really need to just remember? I'll keep it in mind. Keep in mind that this is all because you want to make your work impactful for other people. You want to keep people around, make sure that they also have the joy of using tools that you have built. Now, I do want to do a little bit of a disambiguation. There are two types of personas to keep in mind. There is the user persona, and then there's the developer persona. The developer persona is the one that is just like you, who are creating a tool like a Python package, for example, that encompasses like custom algorithms that other people will need to use. And then the user persona doesn't care about installation setup and development setup. In either case, both are really important to think about, right? Like we use, say, pip and conda as our distribution mechanism. So making sure that when someone else pip installs your package, that they can actually get to work using it and having great examples to help them along. That is a great way to ensure that the user persona is happy with the thing that you make. But then to make sure that you can continue to sustain the project, not even grow, right? Let's just think about sustainability of certain projects. You want to be able to make sure that other people can onboard onto your code base, make contributions so that you can recognize them. They're going to want to make sure that they can get set up as easily as possible. And so this is installing to contribute rather than installing a tool for use. And so for the developers, the developer persona, this is a lot more involved in making sure that you make it easy and document how you would set up for other people on someone else's computer is going to be really important. So what's the impact here then, right? Impact of user-friendly setup is you're going to lower the barrier of entry for potential users and increase the likelihood of adoption of what you build, whatever you build. Also, a smooth and easy setup is for those who are Android users, but man, if you've used an iPhone, it is so easy to get set up, migrate over from an old place. And so you want that magical feeling for the people for whom your project work is going to serve. And that can really, really help with, onboarding as well. So hopefully that the importance of, user-friendly installation and setup is a little bit clearer for you all. Really keep in mind, this is not about us being self-centric, but about other-centered, right? We want others to enjoy the work that we've made, enjoy the tool that we've built, or enjoy the process that are of coming up onto our project and working with us, And so I want to make sure that you're keeping this in mind. If you want to collaborate well, having and make an impact, keep in mind what it's like to be a beginner getting set up. Keep in mind what it's like being a beginner to install the thing and trying to use what you've made. Okay, so the third concept that I want to talk about is about documentation. At Moderna, we place a huge premium on documentation. I've been fortunate to be able to help drive that culture of documentation at work. And it came from this place where when I was in my previous roles, both in grad school and at Novartis, I couldn't scale my brain, right? I could use automation to scale my labor, but I couldn't use documentation I couldn't scale my brain because I wasn't producing sufficiently good documentation. And that played out when I was kind of the point person for how to deploy data science projects on Kubernetes cluster, because I was the first adopter of Kubernetes in the data science community at NIBR when I was there. And I figured out the vast majority of the patterns, but then was like, okay, here's the repo on Bitbucket, go for it. And people would just keep asking me questions. It was not the most fun thing to, it's fun the first time around, but if you're answering the same question by the 15th person, that no longer has any more joy inside there. So I soon came to realize automation scales labor and helps us reclaim the joy of work. Documentation scales brains and also helps to reclaim the joy of work. So good documentation can actually make the difference between a project that gathers dust, hint, hint, my thesis project, which has gathered dust for 9 years now, or it can actually be something that helps onboard lots of people easily onto what you're working on and becomes widely adopted and built upon. So I wanted to share with you that there is a framework that you can check, which is called the diataxis framework for documentation. It is an excellent framework because it specifies that documentation is not one monolithic thing, but actually 4 types, 4 major classes: tutorials, how-to guides, explanations, and references. And they actually serve different roles in a user's journey, because someone needs to start by coming on with onboarding, then they encounter certain problems that they want to solve. So then tutorials really good for onboarding, but how-to guides are good for problem solving. And then once people are comfortable having learned by example, which by the way is the way that most people learn, they learn by example, not by principles. Once they're there at that point where it's okay, I'm comfortable with the thing you've built, but I now kind of want to more deeply understand it, that's when you go into the explanation type of documentation. And of course, at all times, we do need to have references like API guides and that sort of thing that help us understand how, what are the arguments that are present. And what I've come to realize after multiple years of trying to help drive this culture of documentation at Moderna has been that there are some, best practices, or maybe a better term would be same things to do that if you incorporate them into your day-to-day work while doing your programming, while doing your coding, you end up in a better place with respect to documentation. Like the first big one is just to leave your riddled with comments that are helpful to yourself in the future. Contemporaneous comments that say, okay, I'm doing this, I wrote my code this way because I want to accomplish things in a certain way, and because I want to make sure that I'm considering some other external factor that may not be visible to someone else looking at my code. Those are very useful pieces of documentation. Just to make this a little bit more concrete, I might leave inside a company code base this comment that is like, okay, we're using Boto 3. We're not using any other, we're using Boto 3 because to interact with S3 because we're using AWS at the company. That should be well known, but if you are in a multi-cloud setting, right? Like, are we supposed to use GCP's bucket store, or are we supposed to use AWS's bucket store? If you don't leave this kind of commentary behind the scenes, it just increases the friction for someone else to come up and understand what's going on. So contemporaneous, just like leaving documentation, commentary throughout your code base as you're going about it. If you're in a Jupyter notebook, for example, you're doing exploratory work, you had a hypothesis and you want to quickly act on it. And you don't have to write a whole markdown cell. Leave a comment, just leave one comment. I think this might be worth exploring because blah, and then write your exploratory work. There's lots of tooling that is capable. There's lots of tooling that we can use to help improve our Jupyter Notebook documentation, but just leaving those little inline comments can really help. Second one, really important, is that you have language that is newcomer friendly more than experienced person friendly, right? What I've noticed, regardless of whether this is at a open source project or inside a company code base, is that people are going to cycle through, and you're always going to have attrition of people who know what's going on in the code base. So it is, if you want to help and onboard other people onto your code base, it's going to be absolutely paramount that you use language that is friendly, welcoming, and also clear for a person who is skilled, who is clear for someone who is assumed to have the necessary baseline knowledge to contribute. Third thing that I remember that I've learned is that examples are really, really important, right? People, as I mentioned, do not learn first by first principles. They learn first by examples. They want to accomplish what they're doing. So having an example of how to use the thing that you just made, created, and put inside your documentation really, really helps. And so, the inline, what are those things again? Inline within your doc strings, you can have inline Python. I forgot what those are, that can be run by doc tests. Just those kinds of examples are really, really helpful to have around. Yeah, then also keeping your documentation up to date. So regularly reviewing or finding ways to build automation to keep them up to date is really important. One of the tools that I've really enjoyed trying to build within llambot has been documentation checker, out of date checker. So it actually says, like, does this thing where it's like, I have a markdown file that has a bunch of documentation that has been written, and I have described my intents for the documentation, and I point it at where it's supposed to be drawing content from, where this markdown file is supposed to be drawing content from. I have an LLM that helps me do a very first quick pass. Is the documentation that I have provided out of sync with the code that I have? And that can be, when you have a really massive code base, any form of automation that you can try to develop to help with keeping it up to date is also going to be really helpful too. I wanted to share a little bit about how we work, how we make these ideas these three key concepts operationalized at Moderna. These are ways of working that I've, again, have been really fortunate to help to drive forward. And I think they're well recognized as important practices, but they're not always encouraged or enforced. So if you as a person, individual contributor, or if you as a newcomer to, sorry, not as a newcomer, I mean, if you are in a position where you are technically experienced and have sufficient authority, whether formal or informal within an org, I think it pays for you to try to push forward some of these for a data science team or software team. So yeah, what are some of the ways that we operationalize these? So the first one is we actually do code reviews. We treat our work as software, even though we're data scientists, we're not software developers. Nonetheless, we treat our work as if it was software, and we treat it as if it was to be shipped like software. So first off, that prevents us from engaging in one-off, one-by-one kind of very tactical analyses, and instead lets us focus on building out new capabilities for the org. And secondly, of course, is that it means we can engage in activities that look like software development. For example, code reviews. And code reviews mean that make sure that knowledge is shared. If someone else if I try to get a newcomer to a project to onboard and they're having trouble setting up the environment, then I know that I have documentation problem through that code review, and I have a portability problem. I need to improve how we make sure that my stuff can actually work on someone else's computer, which then relates to the second point, where we actually try not to make our work like a bunch of snowflakes that are each their own special little thing. We apply a huge amount of project standardization. So we have standard templates, we have automation that makes sure that we are logged into the right systems as we set up our new project code. We make sure that our Docker files are kept up to date, that our pre-commit hooks are all kept up to date. So there's a lot of automation that we've invested in that makes sure that a lot of the human burden that's typically associated with getting set up, and the pre-commit hooks being like humans, instead of humans nitpicking another human's code, we get bots to nitpick a human's code. And putting these into place really helps us with streamlining how easy it is to get someone else onboarded onto our projects. We also do these Docathons, and I've blogged about Docathons before, but they are a wonderful opportunity to bring people together to be nerds and to just sit down in library silence, in a socially acceptable library silence setting, to be focused for 2 days on documentation. And they're great. They're both great productive work sessions, but they also tend to be team building exercises, because we get people to review each other's documentation, and we make sure people are sharing food together. So food is always a great way to do a little bit of very lightweight team building. As I've learned, you actually don't need very fancy team building exercises. We just have to bring people together purposefully, and that will do the trick. We also do AI-assisted documentation, and I'm sure Leah will speak about it, but I'll give a little bit about how we do it. As I was mentioning before, we do AI. I built a tool to help me with checking the freshness of documentation that uses LLMs. And I know that for me personally, the initial draft is always the hardest to write. So I built tooling that allows us to take in source code and gives me the first draft of documentation that we will need for that source code. And then I can go in and do the actual editing. So usually an LLM can get me about 80% of the way there, which is 80% of effort drafting that I don't have to do, right? And if I can then go in and do the editing and make it really high quality documentation, then that really helps with making sure someone else can understand how to use what I'm doing. So it's through these practices that together we get clean, distributable, well-documented code, which becomes closer to reality rather than a pipe dream, right? That we need to, rather than just a pipe dream, it's closer to reality now. And it allows us to, that standardization, as I mentioned, also allows us to, has secondary impacts not related to today's work, this week's fall festival, but nonetheless, it helps us like really ship high quality stuff quickly with minimal overhead, and allows us to build a community of practice together because of the onboarding documentation that we have. All right, so I'm going to conclude by quickly recapping. There's readability, user-friendly installation, and documentation. If you keep in mind the psychology behind other people who may be newcomers to what you're working on, hopefully these ideas become really concrete for you, right? Readability is important because if we're to onboard a newcomer and they can quickly grasp the patterns that you've established in the code base, then they can quickly get set up with contributing. If they can quickly install or quickly set up the development environment, then again, we've reduced the barrier to entry. And if you have great documentation, you can actually scale how many people scale the number of people that can come and contribute to your work. It's a great form of teaching as well, and through good teaching, you can turn users potentially into contributors and thereby fostering a community around your project too. All right, so as you embark on your next data science project, taking the tools that you're going to learn from this week's Fall Festival, I'd like to challenge you all to do a few things. Prioritize readability right from the start. Take the tools that you're going to learn from this week's Fall Festival, and in your next project, create a smooth installation process for both your users and developers. The third thing I want to challenge you to do is to document as you go. Leave comments all over the place. The more comments you leave, the better. The fourth one, seek feedback early from people who you want to serve with your work. Make sure it's actually serving their needs. For those who want to introduce more contributors, battle test your onboarding docs, right? Like seek feedback there. Where are the bottlenecks? Where are the roadblocks to someone else onboarding onto your project without you being present? And finally, if you're not in a position where you are creating a tool for yourself, then go look at other open source projects and battle test their onboarding guides, battle test how easy it is to get on board. And if you find issues, make a contribution, right? Every little contribution really helps. My first contribution to the open source world was in documentation. It was 70 pull requests to the matplotlib gallery to remove the PyLab examples. I started from there. You can do the same too, right? Thank you very much.